Hi, this is Bradley Bush. I'm going to talk about another topic in calculus today that I think is kind of fun. We're going to find limits of functions graphically. So if you're given the graph of a function, say f, which we have right here, can we find some limits? We have four limits here. We have a, b, c, and d. A is the limit of f as x approaches 0. B is the limit of f as x approaches 2. C is the limit of f as x approaches 2 from the positive. And D is the limit of f as x approaches negative 2 from the negative side. So let's check things out. Here is A. A asks you to find the limit of f as x approaches 0. So our x values are going to be going towards 0, x equals 0, which is right here. And we're going to figure out, we want to find out what the behavior of f is as x approaches 0 from both sides. So notice this is not a one-sided limit because you don't see a plus or minus up here where I just indicated with the yellow arrow. It is an actual limit, so we've got to come from both sides. So it's as if you put your finger right here on the blue part of the curve, and you're tracing the curve as we're coming down, as we're going towards x equals 0 from above. We're allowing our finger to follow the path of the function as we scoot our x towards 0 from the positive. And we notice kind of what the behavior is, where it's going. And then we do the same thing from the left. And if we follow this down as our x is getting close to 0 from the left, we can see that both of those values, both of the y values from the left and the right, are heading towards 0. So here we would say because both sides go to 0, the y value of both sides go to 0 as x approaches 0 from both sides. We see the limit of f as x approaches 0 is 0. How about the second one? The limit of f as x approaches 2. So 2 is right here. This is a limit, not a one-sided limit, so we're going to go from both sides. So we'll be going this direction, and we'll be coming from the left as well. And again, this is our point of interest. So if we trace the function, I don't know what happened there. It just kind of jumped on me. If we trace the function from coming from the right, it looks like the y value is going to go towards 2. So the limit of f as x approaches 2 from the right is 2. And if we come from the left, I'm going to do the left in orange. It's kind of hard to see that that's orange. I'm going to go back to yellow. As I go towards 2 with my x value, and I follow the y value with my finger, looks like the y value goes up to 4. So the limit as x approaches 2 from the negative is 4. Because these two are not equal, meaning they're not the same thing, the limit doesn't exist. So as I'm going from left and right, going towards the x value of interest, so in other words 2 right here, as I put my fingers on the graph and I allow my fingers to follow the course of the graph while I'm scooting them right towards 2 from left and right, my fingers must come together and touch at x equals 2. If my fingers go to a different spot, like I did here, my right finger went to y equals 2, and my left finger went to y equals 4. They are not the same one-sided limit, they're not the same place, so the limit does not exist. So up here, I would say here, this does not exist. So in parentheses, does not exist. So for a function to have a limit, the one-sided limits must exist and agree, and that's just what I showed you here. The limit coming from the right was 2, the one-sided limit coming from the left was 4. Those are not the same number, so the limit does not exist. Let's try C. So C goes from, C's checking on the limit of the function f as x approaches 2 from the right. So I'm only concerned with the right this time. So as I go up, it looks like my y value is approaching 2. So I'm going to say the limit here is 2. And let's look at D. Here the limit is of f. We're looking at the limit of f as x approaches -2, which is right here from the left. We've got a problem here because coming from the left, the function is not defined. So there actually isn't anything there to follow coming from the left. So this limit, I don't know why n always has to come out before D, but it's not supposed to. The limit does not exist on this one either because there's no function here in this area. The function is not defined there. That is it. I have one comment though about A that I thought of. So as we approach 0 from the right, so this way, and then from the left this way, notice the function at 0, the function evaluation, so f of 0 is 2, even though the limit as x approaches 0 of f is 0. So there's a hole right there at the bottom, right here, and it jumps up and we have the function evaluation at 2, y equals 2. The limit is actually completely blind to what happens at x equals 0. The limit can't see anything there. All the limit cares about is what the function or the behavior of the function as x is approaching 0. At actually 0, the function doesn't care. It doesn't even see it. So for us, it doesn't matter that there's that jump. It's not a problem at all. All right, that's it. If you have questions, leave comments in below. If you want to see some more stuff about calculus or limits, check out my calculus playlist on my YouTube channel. Thanks for watching.